Today we're going to do 3.4 on inverses. And your two I cans are I can graph a function and its inverse and find the inverse of a relation, find inverse algebraically. Kind of ran out of room there. So I'm going to put something different in each of these four boxes. So up top, I'm going to put in the definition. Okay, the definition of an inverse is two relations are inverses if and only if. So hopefully you remember this from geometry. It means if and only if one contains the point A comma B, the other contains B comma A. So two functions, maybe they're not even functions, two relations are inverses if like one contains the point 1, 2, the other one contains the point 2, 1. It's kind of like the x and y flip. The notation that we use for this is that you say like f of x is our function, or y, and then this, with this little 1 here, means the inverse of f of x. So like g of x would have an inverse of g negative 1x, like this. Okay? So that's our notation, definition and notation. On a graph, how would you show this on a graph? Okay, so if I said f of x equals 3x squared plus 7. Well, let's kind of go back to some of the things we know. The parent for this is x squared. So here's my x squared table. Where am I getting this? Right off the tables I gave you. 1, 0, 1, 4. Then I'm going to use what I know to make my rule for f of x, which is going to be x and then 3y plus 7. So when I fill this out, I'm going to get this table here. Okay, and you can take your time and show my 3y plus 7 from my table, from this table to this table. So I started with my parent table of x squared. Then I moved over here and I made a table for 3x squared plus 7. Now to show my inverse, I'm going to take my table and I'm going to flip the x's and the y's. So this is my table for the inverse of x. I'm going to take all these x's and put them here now. I'm sorry, all the y's and put them here, because the definition of inverse was that if there's a point xy, then on the new one the point is yx. And then I'm going to take all these and put them here. So you basically flip the x and the y in the table, and I don't have room to graph, but then you would of course graph it. So graphically, you make the table, flip x and y. Okay, the last thing I had on here was to do it using algebra. So algebraically, if I give you the same f of x, I'm going to rewrite this so it says y. And again, I'm going to use like what I have here, flip x and y. Okay, so I'm going to do that for you. So I'm going to have x equals 3. Now I'm going to have y squared plus 7. After you flip your x and y, you need to solve for y. Okay, so we never write a function like this where we say, you know, x equals. We always say y equals when we're writing these. So now I'm going to solve. So to do that, I'm going to subtract 7 from both sides. So I have x minus 7 equals 3y squared. I'm going to divide both sides by 3. Oopsies. I was hoping to shrink down the whole thing and give myself some more room, but it doesn't look like that's going to happen. Just shrink that, I guess, right? All right, so divide both sides by 3. So now I have, move up here, x minus 7 all divided by 3 equals y squared. And then I need to square root both sides, and that goes over this whole thing. So now I have y equals, when you take the square root of something, you get plus and minus the square root of x minus 7 over 3. Okay, and this would be my new function. Now, if you put this in a calculator and graphed it, let me get a new page here. If we put this in our calculator and graphed 3x squared plus 7, we would find that we have something kind of like this. Okay? Inverses have symmetry, and I think I forgot to put it in the first slide, that inverses have symmetry over the line y equals x. So if I drew that in here, okay, I can guess that if I fold it over this line, my new function would look something like this. When you type in your calculator that you want to graph our new inverse function, which is this, I'm thinking, why do I have to put that plus or minus? What's going to happen is, when you graph it, if you just type in the square root of x minus 7 over 3, you're only going to get this portion of it. So you're not going to get your entire line. If you then type in negative x square root of x minus 7 over 3, you'll get the bottom part of the line. So it's important when taking the square root that you include this plus or minus, because otherwise you don't get the entire inverse. Okay? So the things you need to know about inverses. Okay, so inverses, kind of in conclusion, their x's and y's flip. Okay? They have symmetry, meaning if I fold it in half over the line y equals x, and you need to know how to do this with a table, basically graphing it, and by using algebra. And that goes back to the flip x and y again. Okay, so those are kind of like the things you need to know for inverses.